Hey y'all, in this video I'm going to go over some factoring concepts. You should be pausing the video to copy this paper. This first page is like a flow chart, just kind of has helpful hints and reminders of what your answers are supposed to look like. So factoring is figuring out what two things got multiplied together to create what you're looking at. So sometimes it's two binomials, it could be a trinomial, but the very first thing that you want to look for is a greatest common factor. A greatest common factor is any number that can go into your coefficients or a variable that is on every single term. So that is the very first thing you need to look for. All right, after you decide if it has a common factor, you divide it out, then you have to see how many terms are you looking at. Sometimes you have to factor a polynomial that's 2 terms, and sometimes you have to factor a polynomial that is 3 terms. I'm going to come over here to the 3 first because that's a little more straightforward. So when you have a trinomial, that's quadratic. A quadratic is made by multiplying 2 linear factors together. So your answer should look like x plus a number times x plus another number. Now it could be minus. There could also be a number in front of x. But I just wanted to remind you that when you learned how to multiply binomials together, you probably used a box method, or you heard of FOIL or distribute. And basically we're just working backwards from that. So I know that these two need to multiply together to make that first term. I know that these numbers where I have m and n, that's what we're looking for. We're looking for those two numbers that multiply and give us that term at the end. And these two boxes should be like terms. And when I combine those two together, I get the middle term. But your answer should look like two binomials, x plus a number times x plus another number. All right, if your polynomial is only 2 terms, you have to look at the degree. Either you're factoring something quadratic or you are factoring something cubic. And again, find a good time to pause this video so that you can copy this down. So if it is quadratic, if you have x squared as your first term, we call that difference of 2 squares, or dots for short. And basically, it has to be x squared minus a number. That's where the word difference comes from. And a has to be a perfect square. So if I were to multiply them out, I'm going to need the square root of whatever that last number was, that a number. And in order for the middle term to be missing, that means these two had to cancel each other out. So one has to be positive, one has to be negative, and it should be the same exact number because you can only do this if you were able to take the square root of the number that was at the end. All right, and so in this case, your factors would look like x plus and x minus, and then these two, these would have to be the same. And so I'm just going to use m. But the numbers there in place of m would have to be identical. All right, there is also a cubic version where it's only 2 terms. And with cubic, it's allowed to be x cubed plus or x cubed minus. And so that's different. And basically it's because when you had the quadratic version, in order for this to work out and cancel, one of them has to be plus and one of them has to be minus. But for cubic, you have 3. So the signs can be different basically as long as 1 is negative and 2 are positive. You could have a negative. And if 2 of them were positive, or sorry, if 2 of them were negative, it would make a positive. So because you have 3 things going on, the signs are going to get a little bit jumbled up. So cubic, your factor for cubic is going to look like a 2-term polynomial and a 3-term polynomial. So 2 terms times 3 terms. So you're going to see me work it out with a 2 by 3 box. All right, so what you need to realize is this will only work if you can take the cubed root of whatever this number is. So like 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64. So it has to be those kinds of numbers that you can take the cubed root of. All right, and so I have these signs could be plus or minus because it depends on the original problem. Your linear factor should have the same sign. So if you started with x cubed plus, this should be plus. If you started with x cubed minus, this should be minus. This sign is going to need to be opposite. That's how we're going to start canceling some of these boxes in the middle. And that's why your final answer only had x cubed and then a number at the end. It doesn't have an x squared term. It doesn't have an x term. And then you just have to make sure that your numbers still multiply to come out to be what that last number was. And so this should actually say A here. That should say A. All right, so let's get into some examples so you can see it. All right, and I am going to go through these kind of fast because I want you to see these 3 examples. So pause and rewatch if you need to. All right, so this is a trinomial. The first thing I'm going to look at is to see if I can divide all of these coefficients by 2 because that's my leading coefficient. And wouldn't you know, I can. So I'm going to do that first. That is my greatest common factor. So that's going to reduce my trinomial to x squared plus 2x minus 24. So this is a trinomial, which means it's a 2 by 2, a binomial times a binomial. And what I always do is put my first term and my last term inside the box. And the box, you don't have to do it, but it makes it easy to check and see if you have gotten it right. The other thing it helps you visualize is kind of what you're supposed to be multiplying versus what you're supposed to be adding. So x squared, I know I need x times x because x times x is the only way to get x to the second power. All right, and so then these 2 numbers that I put here have to be factors of the number negative 24. I need 2 numbers that will multiply to negative 24. If you are not that good at your times tables, you need to just divide, and every pair that you get that's not a decimal, write it on your table. So 1 times 24, I know 2 times 12, and go in order. I know 3 times 8, 4 times 6, 5 does not go into 24, and 6 I already have on my table. So I'm looking at these pairs, and because that's negative, I know one of these has to be negative. So you might need to guess and check a little bit, but basically I'm looking for the pair that when I combine them will give me positive 2x. So you can guess and check a little bit, but I know that 6 minus 4 is positive 2. So that's the pair that I'm going to use. Now these are your middle terms, and it doesn't matter which one you put where. And again, this is just to kind of help you visualize what you're doing. So I know that negative 4x plus 6x will combine to a positive 2x. All right, so now you just have to kind of look back at what's on the outside and just make the outside match the inside. So in order for this box to be 6x, if that's already x, then this box needs to be 6. In order for this box to be negative 4x, if that's already x, then up here needs to say negative 4. And I can check. Those 2 multiply to negative 24. So my answer is x minus 4 times x plus 6. And the greatest common factor that we pulled right from the very beginning that always needs to go in front of your factors. All right, example number 2. So again, the first thing I'm going to look at is a greatest common factor. I can't divide, there's nothing in front of x cubed, but if you notice, they both have an x term. So if I expand this out, x to the third power is x times x times x. This has an x also. So basically I can take that x out. So my greatest common factor is x, and what that's going to reduce to is x squared minus 49. All right, I'm going to analyze the degree. I see that I only have two terms, and I see that it's x squared. So I have to look at my perfect square numbers. Can I take the square root of negative 49? And I can. And 49 doesn't have too many factors other than 1 and 49. 7 times 7, that's the square root of 49. I know one of them will have to be positive and one of them has to be negative because I don't have a term in the middle. So if I set up a 2 by 2 box to try and check, I know this is x squared, I know this is negative 49. X times x is x squared. If I put a positive 7x and a negative 7x, I can see that they cancel, which is good because there's no x term in the middle. And then if I do the same thing, all right, well, x times negative 7, x times positive 7, I have an easy way to check and make sure that it all works out. So my final answer is the greatest common factor that I pulled at the beginning, x plus 7 times x minus 7. And it doesn't matter what order you put the factors in. So if you put x minus 7 first, that's fine. All right, last example. This is two terms. I don't have any common factors. I can't divide x because they both don't have an x. There's nothing to simplify that I could divide by. So I will notice that x to the third power is cubic. So now I'm looking at taking the cubed root. So if I cube root negative 27, that's going to give me negative 3. So another thing to kind of remember that we are going to need to use is negative 3 times what is going to give me 27, or sorry, negative 27. You are going to need that number as well. So I can tell that that's going to be, I don't know my times tables. That's going to be positive 9. So I will be using 9 in this as well because it's like a missing factor for negative 3. All right, so I like to start this by setting up a 2 by 3 box. I know this has to be x cubed, and I know by the time I'm done, this has to be negative 27. So I know that my linear side is just x. That needs to be x squared. I'm going to take the number that was my cubed root. That needs to go on my linear side. I know negative 3 times positive 9 is how I'm going to get negative 27. And from here, it's just kind of like a fill in the blank. These two boxes need to cancel. And these two boxes need to cancel. So if I start multiplying out, x squared times negative 3 is negative 3x squared, which means this box needs to be positive 3x squared. So what needs to go up here? Well, what number times x will give me 3x squared? This needs to be a positive 3x. And then you can check. Basically, the rest of the box is just to check. That box would be negative 9x. This box would be positive 9x. So that's perfect. They are canceling. So my final answer, x minus 3, x squared plus 3x plus 9. Same sign, opposite sign, always a positive. And if you notice, I basically used the cubed root number, and then that missing factor.